We already know what is a bifurcation. We studied it on the example of this system. Now let's talk about the types of the bifurcations. Here we have a transcritical bifurcation. We can see the bifurcation point r equals 0, and when our r is negative we have two equilibria, x equals 0, which is stable, and x equals r, which is unstable. After passing the point r equals 0, we have opposite case. Our equilibrium x equals r becomes stable, and equilibrium x equals 0 becomes unstable. This is transcritical bifurcation. Supercritical pitchfork bifurcation. Here we see we have bifurcation point r equals 0. When r is negative, we have only one equilibrium point, x equals 0. After passing the bifurcation point, we have 3 x equals root r, x equals minus root r, and x equals 0. And x equals 0 is unstable, and x equals root r and x equals minus root r, those are the stable equilibrium points. This is supercritical pitchfork bifurcation. Subcritical pitchfork bifurcation. It looks like the previous one, but reflected with respect to vertical axis and slightly changed with the curves. So when r is negative, we have 3 equilibria, 2 unstable and 1 stable. After passing the point r equals 0, 2 unstable equilibria disappear and our stable equilibrium becomes unstable. So the equilibrium points are before r equals 0, we have x equals root r, x equals minus root r, and x equals 0. And when r is positive, we have only x equals 0. This is subcritical pitchfork bifurcation. Now let's look at the systems of the second order, and let's start with saddle node bifurcation. Our changed parameter here is mu. When mu is positive, we have 2 equilibrium points. One is unstable, another is stable. When we are passing through the point mu equals 0, we see the following. When mu is 0, we have only one equilibrium point. And if we move further, when mu is negative, we don't have equilibrium at all. Supercritical Hopf bifurcation. We have the other variables r and theta here and several parameters, but let's look at the parameter mu. When mu is negative, we have one equilibrium and the phase portrait is stable focus. When mu is positive, then that point becomes unstable and looks like unstable focus, but we also see closed trajectory, a closed orbit appears, and here we have a stable limit cycle. This is supercritical Hopf bifurcation. Our last type is subcritical Hopf bifurcation. We have the variables r and theta, and we have several parameters, and as we did before, let's study the bifurcation for the parameter mu. When mu is negative, our phase portrait looks very complicated. So we have two closed orbits here, and we see one closed orbit, outer closed orbit, is stable, and the inner closed orbit is unstable. And also we have this point which looks like a stable focus. When we have mu positive, then we have only one closed orbit, and this closed orbit is stable, and the point which was the stable focus previously becomes unstable focus. This is the subcritical Hopf bifurcation.